Vanakkam. Welcome to this course on biomedical instrumentation. We are looking at various types of sensors. In the previous class, we looked at resistive sensors. Some specific examples of resistive sensors that are used in biomedical applications. We started out our discussion with strain gauges. Although strain gauges are used in various industrial applications, they also have specific applications in the medical field. So we looked at the biomedical applications of strain gauges, and we looked at gauge factor and what materials have what gauge factor, and we also looked at temperature sensitivity and stability and other such things. Then we looked at thermistors, and when we are discussing thermistors, we said that the thermistors have this specific property that we exploit to our advantage. What is this specific property of thermistor material? That is, it has negative temperature coefficient. That is, if the temperature reduces, the resistance increases. This is quite unusual, very different from metals. I also asked you to check why this is the case. Why this is the case in metals and why this is happening in thermistors. This is the principle of operation, but I'm asking you to check why is it happening like this? What is the physics? What is the science behind it? It's useful for you to know not just what is happening, but also why is it happening, because that will give you a deeper insight. I mean, I can tell you that, but it will be even more joyful for you if you discover it by yourself. Why is it happening like this? What is it that is causing such special specific properties? Something that we missed discussing in the discussion on thermistors are further applications or advanced applications of thermistors. We did discuss some of the applications, but some other applications are, for example, are we did mention that we can use multiple Wheatstone bridges to improve sensitivity and reduce lead resistance. We also mentioned this in a previous this that we can use eight arm Wheatstone bridges. That's another idea. And we can use biocompatible material such as polyurethane or epoxy material, and so that we can use them as a compliant biocompatible diaphragms. That is another idea. And we can use special materials, foil gauges, to be used inside an MRI machine. And there are such applications where we need to use non-ferromagnetic materials and materials that are not ferromagnetic. And there are some special materials to avoid ferromagnetic materials, because MRI with high magnetic field will cause unwanted disturbances. Sometimes that can be dangerous also if we use ferromagnetic materials. So there are some special materials that we can use. So MRI compatible materials that we can use in. And there are such applications, there are such needs in biomedical engineering where we need to measure temperature while the person is inside an MRI machine, and so on and so forth. But there are other applications, and specifically, if you are interested in measuring cardiac output in a bedridden patient, then we can place a thermistor inside. That is, what is the thermistor? This is a negative temperature coefficient material. We can place such a thermistor on a catheter tip, and then when we introduce a cold bolus, that is a small substance, small amount of cold substance, by how much does the temperature change? This approach towards measuring cardiac output is called thermodilution. Please do check and read about this. This is a measurement principle. This course is on instrumentation. What is thermodilution? How is it used in biomedical applications is something that I request you to please check by yourself. But briefly, what this means is that we introduce a substance at a different temperature, and we know the volume of that substance, how much and what is the temperature of that substance. And as we are measuring the temperature by how much the total volume changes, it is possible for me to estimate the total volume, the cardiac output of this. Now, that is the principle of operation. Please do check. This is very brief. Please do check the details of this. Another application is in the management of hypothermia. What is hypothermia? Hypo means less. Thermia means temperature. That is, when a person goes into a situation in which the temperature is reduced by a lot, a sudden temperature drop in the person. When would this happen? When the person is in a very cold space with no protective layers. For example, cold spaces, Arctic, Antarctic, or other cold places in the world where during the cold seasons this could happen, hypothermia. A lot of people die of hypothermia. In such cases, there is a need to measure temperature of the person who is affected by hypothermia, because in such cases it's very difficult. It's an extremely challenging situation to treat and manage. In such situations, there is a need to measure temperature inside the body, for example inside the esophagus. So in such cases, thermistors are used. Another critical application of thermistors is in the management of neonatal temperature. Neonate means newborn or an infant. Babies less than 28 days old are called neonates. Infants less than 28 days old are generally called as neonates. Some babies are born before term, preterm. Now, even term babies do not have sufficient thermal management capability. Preterm babies definitely do not have thermal management capability like children or adults. So they need to be covered. That is why you can see that moms, parents in generally swaddle the kids and keep them warm. There is a need for them to be kept warm by providing external covering. This is called as swaddling. 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 There's a particular way in which you have to use a blanket to cover the baby so that the baby will stay warm but still continues to breathe. It's very critical. Of course, this is also the reason why moms or dads keep holding the babies close to their body with body contact, not with clothes on. You know, without clothes, the parent holds the baby close to their body so that the warmth of the parent goes to the baby. These are cases in which the child is relatively healthy. But if the child is a preterm baby requiring ICU attention uh, and admitted in what are called as a neonatal intensive care unit or NICU, NICUs, then there is a need for ambient temperature monitoring. The baby will need to be kept at a particular temperature. And you need to measure what is the body temperature of the baby and what is the incubator temperature. And likewise, so that means you will need a closed loop control system that manages this temperature. That means that you will need a relatively accurate and reliable measure of temperature. In such cases, and by the way, this is a very sensitive issue. Everybody is very specific about caring for their babies. So that temperature management is a huge challenge There are companies that specialize in providing incubators and providing closed loop solutions for you know um, managing temperature, not just temperature, providing other things. For example, sometimes, but not always, babies require lighting to avoid neonatal jaundice, for example. In such cases, lighting is provided. So uh, a one-stop solution that provides lighting, that provides warmth, that provides so many other things are being provided by some companies. Please do check it. There is actually an Indian company that is specializing in neonatal incubators. Started by one of our institute alumnus. You can check who it is, what it is. There is an Indian company that provides neonatal incubators that specializes in this. And remember, it is absolutely critical to use the temperature information to provide control. So you need a closed loop system, and a critical component of this closed loop system happens to be the temperature measurement unit. And that application, that measurement system usually is a thermistor. And because we are also interested only in a specific range in this case, no, we are interested in maintaining the temperature between, say for example, between 33 and 37, or 32 and 38 degrees Celsius. This is our interest. So in such small ranges, thermistors are excellent choices because they have linearity in small ranges. That is where this application is used. The other application that we mentioned early on in one of the earliest mentioned in our previous discussion, in today's discussion, is that uh, thermodilution. It's also called as a Swan-Ganz thermodilution cardiac output measurement method. We will continue our discussion on capacitive sensors in the next video. We will stop here.